Good day to everyone. So here we are again to have a new discussion in regards with hypothesis testing. So this time we'll be discussing about independent samples t-test and give out example on how to compute or do a t-test analysis. Um, so let's proceed. So the independent samples t-test, this is also called the unpaired samples t-test. So basically, this is the most common form of t-test. There are also other types, let's say paired t-test, etc. And then this kind of t-test basically helps you to compare the means of two different sets of data. For example, let's say you will run a t-test if you want to see if the average scores of a males and females are different. So that means you want to know if there is a significant difference of the test scores when grouped according to gender, which is male and female. So one important term in independent sample t-test is the standard of error or standard error. It is the variance within each of the two groups and this number of subjects in each of the two groups. So this is the formula of standard error. Okay, it is the variance, a square root of the summation of the square of the first square of x, summation of the square of x first data, and then plus the summation of the square of the second data, or x sub 2, divide the number of items in the first group, plus the number of items in the second group minus 2, then multiply it with 1 over n, the number of items in the first group, plus 1 over the number of items of the second group. So this is the formula for t-test for independent samples. So if this t ratio is equal to 1 or less, so the observed difference basically between means is probably due to chance alone, kung equal to 1 siya or less. So, chance lang siya. That means doesn't have any significant difference. So, the observed difference is less than the difference expected by chance. So, therefore, the null hypothesis is retained. So, that means wala tayong sufficient evidence to draw in a conclusion that there is a significant difference. So let's have an example. A physical education teacher conducted an experiment to determine if archery students perform better if they get frequent feedback concerning their performance or do better with infrequent feedback. She randomly divided her class into two groups of 15 and flipped a coin to determine which group got frequent feedback and which group got infrequent feedback. So she set her alpha level in 0.05 for a two-tailed test. And at the end of her study, she administered a measure of archery performance. So this is the table of the scores and the feedback of each groups. Okay, so the scores of those in with frequent feedback. Okay, so there are, I believe, 15, all of them. So these are the scores. And then the summation of scores is 210, and the number of items is 15 in the first group. And then you get the square of each values or scores in the first group. So ito yung result. And then the summation of all square of values of x, or the first group, is this 3046. And same goes with the group 2, the second group with infrequent feedback. So the first thing we need to do is to define the hypothesis of the problem. So first we need to define the null hypothesis. So there is no significant difference of the archery performance of students in frequent feedback versus infrequent feedbacks. So the alternative hypothesis, if the null hypothesis will be rejected, so we'll be accepting the alternate hypothesis. So the alternative hypothesis is there is a significant difference of the archery performance of students in frequent feedbacks versus infrequent feedbacks. So this is the computation formula of the independent t-test. So we will be we'll be inserting the numbers from the table into this formula. So it gives us these results. So um, uh, the difference of the the value of x, the first group minus the second group. So 210 divide 15 minus 150 divide 10. So square root of the summation of the square of the first group, which is 3046, minus the summation of the first group, the value first group, square of the summation of the value of this first group, which is 210 square, divide the sample size of the first group, which is 15. So plus 1590, which is the summation of the square of the second group, minus the square of the summation of the second group, divide the sample size of the second group, which is 15. And then divide by 15 plus 15 minus 2, and then multiply it by 1 over 15, which is basically the sample size of the first group, plus the times plus 1 over 15, which is the sample size of the second group. So computing it, we get the calculated t into 4.14. So this is the calculated t-value, which is 4.14. So we already have our calculated value. So we observe that the difference of it is that 4.14 times as large as the average difference expected by chance. So it is a lot larger than 1. So that means it is not by chance alone. So we will further investigate if there is a significant difference. So is it really large enough, to reject the null hypothesis? So hindi siya diretso na we will reject. So we will need to further investigate. Kasi nga, it's greater than 1, di ba? So it's not by chance alone, but is it large enough to reject the null hypothesis? So we will need to further investigate by considering the t-curves and the degrees of freedom of our sample. So the number of the degrees of freedom is the number of observation free to vary around the parameter or the constant parameter of our sample. So we will now decide if we will need to accept or reject. So first is we need to find the degrees of freedom using the formula n is the number of samples or responses in a group. So with this formula, we get degrees of freedom of our problem is 15 minus 1 equals to 14. So since two-tailed yung gamit natin, two-tailed t-test, so we need to do to sum up the first degrees of freedom of the first sample and the degrees of freedom of the second sample. So that means 14 plus 14, which is equals to 28. So that is our total degrees of freedom. So we need to look up the degrees of freedom, which is 28, in the table of our appendix, which is available in our module in the alpha level of 0.05 for two-tailed test distribution. So this is our appendix A. Actually, nag-start yan siya sa 1. So I just exploded it with, mag-start siya sa 18 to 30. So we need to find, we already know that 28 yung degrees of freedom natin. And then our test is a two-tailed test distribution and our alpha level is 0.05. So from there, we'll just need to cross-reference the 0.05 two-tailed test alpha level with our degrees of freedom of 28. So that means our T critical value is 2.048. So accept or reject. So we find that it has 28 degrees of freedom at a level of 0.05 of, so that means our T critical value now is 2.048. So we will now compare it with our T calculated value. So again, our T calculated value is 4.14 and our T critical value is 2.048. So by standard definition of this is that if the T calculated value is lesser than T critical value, we need to accept the null hypothesis. Otherwise, we need to reject the null hypothesis and support the alternative hypothesis. Now, in our case, 4.14 is lesser than 2.048 is basically false. So that means we need to reject the null hypothesis and accept the alternative hypothesis. So this means that the students increase their performance when they receive frequent feedbacks than infrequent or no feedbacks at all. So by definition, our alternative hypothesis is there is a significant difference among the those who have gotten a frequent feedback. Okay, there is a significant difference of the archery performance of students when grouped according to type of feedbacks or infrequent feedbacks versus infrequent feedbacks. So we can now dare say that students increase their performance when they basically receive frequent feedbacks. So, than those students na hindi naka-receive ng uh, feedbacks or wala talagang feedbacks or the feedbacks is not frequent. Okay, so that ends our presentation of our independent samples t-test. So I hope you learned something today. Please do not forget to like, subscribe, and hit the notification bell. Again, thank you for listening.